what we'll be doing is we'll be looking at some machine learning basics, like what is basically machine learning and how does it actually learn and helps us in our day-to-day jobs, or like predict. We talked a lot about like predicting next word, or what are the basics of machine learning. I'll keep it to a minimal so that just to give you an high level understanding of how it works behind the scenes. We'll look at two major categories of machine learning, which is classification plus regression. And then we'll look at, we always we always see that the models learn, right? We learned in the last class that it's not any if and else condition or any reasoning, like basic database lookup. All those things are not going on in a model, but it learns, right? So I will see into, like, when we say it learns, right, what does actually go behind the scenes. And then we look into neural networks, like what are neural networks, because they are the neural networks is the machine learning model. It's a very powerful concept. All the modern LLMs and everything, or the modern machine learning algorithms, right, they all use neural networks behind the scenes. And just one thing before I start is, like, today's class will be there will be a little bit of math involved when we look at this part, like how does any model learn. So, I mean, it's basic math only. So don't be scared or anything that we have to go through this math, we don't remember and all those things. It's just to, I'll bring in the math so that you understand the overall intuition, that how is the model actually learning, so that no machine learning model is a black box for us. Okay. With that, let's get started. Okay. So our agenda for today is machine learning and neural networks, right? So what does an ML algorithm actually do, right? Any ML algorithm, what it does is it has some past data, okay, some data collected from the internet or some kind of past data. It looks at that past data and tries to learn patterns, right? What is the relationship between the data? It learns those patterns, and then after it learns those patterns, right, it can predict the answer for new unseen data. Okay. Any machine learning model, whether it's a neural network or any other hi-fi any model, right? It does the same thing. It will look at the past data. It will learn patterns from them. Then once it has learned the patterns, you give it new data, new unseen data, and it should be able to predict output for you. Okay. So this is overall what a machine learning model does, right? Now, machine learning algorithms are basically classified into two categories. Okay. One is classification and the other one is regression, right? What is classification, right? Classification, you can think of it as like it will just you give it an input set or input data, and it will classify it for you. Like, let's say if you give it 100 pictures of cats and dogs and you train it on that data, then if you give it an unknown picture, it will categorize it or classify it whether it's a cat or a dog. Similarly, if you give like 1,000 emails and mark them as spam or not spam, and if you give it a new email to it, it will be able to tell the category whether it belongs to the spam category or not spam category. So here the output is just a category. Okay. So these ML algorithms are called classification algorithms because they are basically classifying or like putting the output is basically a classification. So they are called classification ML algorithms, right? And the other set of algorithm is called regression. Okay. So what is regression? Where, like, let's say if you have let's say the price, you have like the price of certain flats or models based on different sizes, what is the number of bedrooms, what is the SFT, and now you want it to predict the price of a new flat based on like an SFT, or like, let's say the size that you provide it, or let's say you give it the temperature data of last 4 5 years and you want it to predict the temperature which will be there in during this summer, right? So the output is always a number over here. So those kind of models are regression models, right? So two machine learning models are there. All models can be categorized into two categories. One is classification, the other one is regression, right? And all, like I said above, all machine learning models, how do they learn? Is like they have some past data, and then humans will label the past data will be labeled by humans, right? For this particular example, right, for prediction of whether a picture is a cat or dog, what I mean is, like, you have some past data. Now a human will come up, like, let's say if you have 100 pictures, right, a human will come and say that, okay, it will label all the 100 pictures that it is a cat or a dog, right? That is human labeling. Now, looking at this past data plus the human labeling, the machine learning model will learn. Okay. And now when you give it a new picture, it will predict for unseen data that it's a cat or a dog. Okay, so this is the overall picture of how machine learning model works and what is classification plus what is regression. I will take a few more examples so that it becomes clear what is classification versus what is regression. Some real life scenarios, it makes more sense, right? Let's say like you have an email spam classification system, right? What a model. What the problem it solves is, given an email, you just need to predict whether it's a spam email or not or not a spam, right? So now what is the past data in it, right? And how it has been labeled. So let's say this is my past data, which I can get from the internet or somewhere, that this data is already present to me with some emails given, right? Win a free iPhone. So a human will come in and know that these kind of emails, if they have this in their description, right, it's a spam. So the data will be marked as spam, right? Email to meeting at 3 p.m. tomorrow, nothing fishy in it. So it will be marked as not spam. Email 3, click here to claim your price. Again, like clicking, claiming price and all those things are related to spam. So this will be marked as spam. Hey, you are free for lunch. This also looks like an okay thing. So it will be marked as not spam. Congratulations, you have won 1 million, right? So these are all things related to spam. So it will be marked as spam. So this is the past data on which the model will be trained, right? And based on experience or something, we can look at this data and humans will label this data, right? Now, what the ML algorithm will do is it will go through this data and it will figure out that if we use words like free, win, price, click, right? They basically appear when it's a spam. So it will learn this pattern. Okay. And words like meeting, lunch, tomorrow, they are like they do not contain and they are like general words. So it will not classify them as spam. Okay. So this is how the ML algorithm will basically work, right? So this is an example of classification. Now you will give it one email and it will and you will ask it to classify it whether it's a spam or a not spam or not a spam, right? So this is an example of classification. What an classification ML algorithm does, or what is actually classification. Now let's take an example of regression, right? What is regression? So let's say the problem is you order food on Swiggy or Zomato. The app tells you your food will arrive in 35 minutes. How does it know that, right? So here, see, the output is a number, right? It has to predict something which is a number, right? So how does it work? So again, it has some past data wherein like you have some data that the restaurant distance is 2 kilometers. If the time of the day was 1 p.m. and it was raining or not raining, no. Restaurant prep time is 15 minutes. Then the actual delivery was 25 minutes. This is a past data which is available. Again, restaurant distance is 7 kilometers. Time of the day is 8 p.m. Raining, no. Restaurant prep time is 20 minutes. So the delivery time took 45 minutes. So these things were observed and fed to the algorithm, right? So now what it does is, now the algorithm will learn these patterns. Okay. What are these patterns? Farther the restaurant, longer the delivery time. If there are peak hours 8 to 9, there will be roads will be busy, longer delivery time, right? If it's raining, traffic slows down, longer delivery time. Longer restaurant prep time, longer overall delivery. So it will learn these patterns from the past data that we provided it over here, right? Over here. Now what it will do is, like when you place an order, right? And that it will figure out the restaurant is 4 kilometers. It is 7:30 p.m. It's not raining. And the restaurants generally, a general prep time for restaurants is 15 minutes. So it has learned from all these things. Now it will be able to accurately predict that it will take overall 35 minutes to for the delivery to occur. So over here, see, classification, the output was a category, whether it's a spam or not a spam. And for regression, the output is a number. It's not like a categorization that it's fast or slow, but it's a definite number. So all ML algorithms are classified into two things. One is like classification, other is regression, right? Now, like I said, we can see the pattern. Every single ML algorithm follows this, right? You give it labeled data, it finds pattern, it produces a model, right? With some facts or whatever it learns, and then you give it new data and it will apply whatever it learned to predict the answer for you. Okay. So, but the interesting part over here is, how does it find the pattern, right? I mean, it's very easy to say that it will learn all these things, but there has to be some mathematical explanation of like, how does it learn the pattern, right? So the basic algo for it is, so what the algorithm first will do is, in initial stages, it will know nothing. So it will just make a random guess, okay? since it's making a random guess, it can be right or wrong, right? So at the next step, what it will see is how wrong the guess is, or like, is there an error in my guess, right? Based on the real answers, because we have labeled the human data, we have labeled the data, right? So it can figure out that this was my past data. I am predicting this, but from my past data, I know that I'm predicting wrong, right? So what it will do is it will adjust its parameters that, hey, I'm predicting wrong. Let me adjust my internal parameters. It will make some adjustments, and then it will try to again predict the data. Okay. Now again, two things can happen. It can go wrong, or it can get it right. Right. So if it's wrong, it will keep on repeating it. If it's right, then it's well and good. We know that it has done the job. How will we know whether it has done the job or not? We compute a loss function, or we compute the error based on the past data. And if the loss or the error becomes zero, we know that the model is trained right now. Eventually, the predictions of the model will become correct, right? So this is the overall process of how a machine learning algorithm learns, right? So it will, so I'll just summarize what I said. What it will do is it will make a random guess first, right? So since it's a random guess, it can be right or it can be wrong. It will calculate that how wrong was it, right? And then what it will do is it will correct itself. Okay, I will adjust my parameters so that I get to the right part, right? So it will keep on repeating this process until it gets it right. And how does it know it has got it right? Because we have the past data, right? Where we know that, okay, this was the answer, but this is how I was predicting wrong. I will take a few examples and explain this part in a lot of detail so that you get this part correctly, because every algorithm does the same. Any machine learning algorithm does the same thing over here, right? So before I move to the next part, are there any questions on this part, like classification? What is classification? What is regression? Okay, I'll take that as a no, but I have one question for you. Is like, in the last class, we have learned about LLMs, right? So can you tell whether it's a classification algorithm or a regression algorithm? Anybody, you can, I mean, you can take a wild guess. It's okay to be wrong. Okay, let me give you an hint. What did we learn in the last class is the only work that an LLM has to do is predict the next sentence, given a set of input sentences. Predict the next word coming in the sentence. Right? We learned this, right? The LLM does one thing, just predict the next word in the sentence. Uh, yeah, guys, anybody wants to take a shot at what it is? Which type of algorithm do you think it is? I'll give you 1 minute to think. Just think it, the answer is there. Okay. Okay, I'll answer that for you guys. So it's a regression, right? Because what is happening is, see, based on past data, we were predicting the output, or we just want to predict the next word which is coming in, right? It's not a classification that I'm doing some classification that this is my input sentence. The answer is a category, right? No, I'm just predict based on my input sentence, what should be the next word, I'm predicting that, right? So it's a regression. It's the LLM is basically a regression model. I hope this is making sense, or yeah, how is it? Did you guys get a hang of like what is classification and what is regression? Guys, speak up. Yeah, it will help. Yeah, feel free to ask questions, or yeah, if you didn't understand anything, I'm there to explain it again.
Hey, one thing, whether it is spam or not spam classification is there, right? That way there can be a number of classifications, right?
Yeah, correct.
Okay.
So based on your problem, right, it's not that there is one specific model for classification. Based on your input data, it will automatically learn that this is the problem that I want to solve. Now, if I have to classify, I'll put it under one category. So it will go through the entire data set, and then it will create categories among them, right? So that way it will be able to like classify. When you give it new data, it will be able to classify it into one of the categories. It's easy to have a mental map when you take this email example. So that's why I gave this example. Yeah.
Okay.
Okay. Let's move on to the next part. So we learned about ML algorithms, right? So what is neural network? Where does neural network come in, right? So what a neural, so over here in the above two examples we saw, right? There was a fairly direct relationship between the data and the problem that we were solving for, right? What we wanted to do is like we wanted to predict the delivery time, right? So there was a clear relationship that if the distance is more, right, the delivery time could be more. There were other factors also, but there was kind of a linear relationship. If it has a word free, then likely it could be a spam, right? Very direct kind of relationships were there, right? So these for these simple kind of problems, simple ML works, right? But where does neural network come into picture? Like let's take an example. Like let's say if you have this sentence, right? I deposited money at the bank, right? I sat by the river bank. We have the word bank over here. Now we have to infer like what does bank over here, or the ML model has to like summarize this, right? So it has to have an understanding of all the words in this particular sentence, right? So how does it understand that the bank over here means a financial institution and the bank over here is a river body, right? It's not a simple problem to solve. If you look at these two sentences, right, how humans figure it out, right? I will look at the whole sentence. I deposited money at the bank, right? So I see the word money and deposited, and then from that I can infer that okay, it's a financial institution that I'm talking about in this particular sentence, right? And I sat by the river bank. Here I see river coming before the bank, right? So then I infer, and sat also can. So then I can infer that bank is a basically a water body that I'm talking about, right? It's not very easy. It's not an easy problem to solve because there's no direct relationship over here. The above problems that we saw had direct relationship, but here it's not a direct relationship. We'll have to be more intelligent. We have to take a layered approach to solve this problem, right? So how did we figure out we did check this part by looking at the context of the words. Now, what simple ML cannot do is if you tell it that bank is equal to money place, right? It will get the second sentence wrong, right? And if you tell it, like if you hard code it that bank is a riverside, it might get the meaning of the first sentence wrong, right? It has to take a layered approach of understanding the words that came before it, then only it can solve the problem, right? So this problem requires more than direct relationship. That is where like neural networks come into picture, wherein like they take a layered approach. They are more intelligent than normal machine learning algorithms, and they take a layered approach where they understand the semantic meaning and then answer the question. So that is when like neural networks become handy, and they are needed because more powerful ways are needed to solve a problem, right? Similar, I will take one more example so that you understand that why simple ML algorithm cannot solve this problem, right? Let's say if you have a translation service and you have to translate from English to Hindi, okay? Now let's say if you have an English sentence, right? I have a dog, right? Which is like 4 words. Now, if you have to translate to Hindi, right? It's not that you can do a word to word translation, because the Hindi translation of the same thing is मेरे पास एक कुत्ता है, right? It is 5 words if you see over here. So if you try to translate I have a dog like word by word, it will not work because it's not possible. You have to understand the verb, the grammar, and everything, and then only you can translate it to other language, right? And if you take Hindi as well, right? This mere paas ek kutta hai, and if you try to literally translate it into English, you will again get it wrong, right? It will come to near me one dog is, which is like grammatically wrong, and it's the wrong meaning which is coming up over here. So what I'm trying to convey is translation is a difficult problem to solve. There's no straightforward relationship over here by which I can do a translation over here. So these kind of problems which are difficult to solve, right? Simple ML cannot solve it. Those are solved by neural networks. Okay. Similarly, if I take one more example of a English sentence, I know Hindi, right? So the Hindi version of it will be मुझे हिंदी आती है. See, here there are 3 words and the translated translation is 4 words, right? So you cannot basically rely on word to word translation. So what we need to do translation over here is first read the English words, right? Then understand the grammar. What is the subject? What is the verb? What is the object, right? And how are they related? Then understand the full meaning. What am I trying to say over here? And then you can do the translation in Hindi, right? So this is a difficult problem to solve. ML, like straightforward ML cannot solve it. So that is wherein neural networks come in. Neural networks are nothing but a neural network is an algorithm that learns complex patterns by breaking the problem into layers of simple steps. Each layer understands a little more than the last until the final layer has enough understanding to give the answer, right? So simple ML has raw inputs, directly jump to the answer because there is a linear relationship. Neural network, we have raw inputs, but we have to first find simple patterns in that raw data, combine those patterns, have a higher understanding, and then answer them. So that is where neural networks come into picture. We'll talk about more into neural networks later. And but I want to talk about one point, like why is it called neural? Because it is loosely inspired by like how our brain works, right? When you see an object, you cannot, like right now you feel that you can directly identify an object, right? But when you see an object, there are certain different kind of neurons in your body which fire, and they are like different levels. Like it's not like one brain function fires and you you can identify the object. There is one thing which will look at the object, it will identify the shape, the another neuron fires, then it will tell you okay it's a circle, then it will tell you okay some other thing, and then you get to the final output. So this is how our brain works, right? So this whole neural network thing is inspired by our brain, so that is why it's called neural networks. You will develop a better understanding for it when we talk about it later, but I just wanted to give you an high level overview of like what are the different machine learning algorithms, classification, regression, and then why is actually neural network required, right? Because LLMs, they will heavily use this neural network concept, right? While we don't have to code or get afraid about all of the things that we are talking about, it will be easier. But just to develop an understanding, right, we need to do this, right? So I'm going through this exercise. Now, we talked about this part, right? Which is, I said, okay, how does it find pattern, right? This is very interesting part where we see where I said that the first it makes the random guesses, it looks at the data, makes random guesses, then it corrects itself, and eventually we get to learn the pattern and answer for new data, right? So what we'll do is we'll do a simple exercise to understand that how does it work internally, right? So I have one exercise for you. You guys have to answer this for me. So I'm giving you some data that I have a value of x. For that, I have this y, value of y. I have value of x2, and I have a value 5 for it. I have 3, I have 7, I have a input value x as 4, and I have output as 9. Now tell me, based on this data, what will be the value of y if I give the input x as 5, right?
11.
Yeah, it was pretty quick, Swati, right? You figured out it's 11, right? How did you figure out it's 11? Can
There was
you?
a pattern.
Yeah.
Yeah.
What was the pattern?
2, 3, 4, 5, 6 is the difference.
Correct, right? So if you see over here, it's something like this, right? If one, so I'm mapping it to a function f. I'm telling why I'm mapping it to a function fx, right? So what it means was like basically how you figured it out was maybe this kind of pattern was there in the data, right? So let's say this is the output, right? You could see that I have to multiply this number x by some input and then do some addition, right? Basically, right? Like 1 was the input and 3 was the output, right? So how did you figure out 1 into 2 plus 1, right? So if I have to generalize this, what I will say is like if I have to predict the output, it could be multiply this x, which the input y have, by some variable, and then I'm doing some addition as well over here, right? Similarly, if I take for 2, the output is 5, right? So what I'm doing is my x is 2, I have to multiply it by a number. I don't know that number yet, and I have to add something also over here, right? Similarly, for 3, how did you come to a conclusion? I have to multiply it by some certain factor and also add something over here, right? So this is a pattern which, I mean, you came up with it very quickly, but your brain did that processing very fast. But internally, it came to a conclusion like this only by looking at this data, right? Is it making sense that why I'm talking about this equation, or can you map this thing to this equation? It is very important to understand this. If you have any questions, please ask this right now, because then I will go into some logic. But is this part clear? Like how this data to answer what will be the input, what will be the output for 5 is mapping to this particular equation?
So neural networks is taking care of building the equation.
Yeah. It will take care. Yeah. Obviously, neural network is taking care of building the equation. But for this, can you see the pattern, right? To answer the output value of 5, I have to get to this particular equation somehow, right?
Mm. Okay.
Right? So now one way I feel that, okay, I have to look into this pattern. Now I have identified that I have to multiply, this is one variable. I will multiply that by x, and then I have to do some addition, like I explained over here, right? So if we have to do it randomly, right? We figured out that this is the equation, right? Now we have to test also on the data, right? Let's say you try it by like putting in values, right? A1 and then B1, right? So what is it? What will the equation become? Y will be 1x plus 1, right? So if I put it in this data, what will it look like, right? 1 is the input, 1 into 1 plus 1. So the predicted output is 2. So I see that the output was 3, but I'm predicting it as 2, right? So, okay, let me take a step back. So what I'm trying to say, what I'm trying to map to is this step. What did I say? The algorithm starts by knowing nothing, makes random guesses, right? So the algorithm figured out that there is some kind of relationship like this, but I don't know if this is right or not, because it could be something else also, right? I have to validate this theory that to answer 5 to get to an answer for 5, and this is the right equation, I have to figure out. So what I do is I make a random guess that A could be 1 and B could be 1, right? So I try out randomly, right? And then what I do is if A is equal to 1 and B is equal to 1, I try to see the output. Okay, so what is the, and I'm calling that as Y star. So this is my input data, forget about it, right? Now what is my Y star? If I take A is equal to 1 and B is equal to 1, 1 into 1 plus 1, 2. Okay, and this data I already have, like I said, right? This part I already have it. I gave you this data, right? So it's making a random guess that I can take A is equal to 1 and B is equal to 1. So I see that the output was 3, but the output when I take A1, B1 is equal to 2. So the error is 1, right? 1 unit is the difference. Similarly, if I take it for this value, 2, what it will be? 1 into 2 plus 1, right? So it will be 3, right? But in my actual data, what I have given you is 5, right? So the error is 2, right? It's somehow not making right predictions. We have an error in the process, right? So now it says that now let's see for this data point 3, right? So 1 into 3 plus 1, right? So it is 4, and the actual output was 7. So it sees the error as 3, right? Similarly, it will do for 9. Similarly, it will do for 4. 1 into 4 plus 1. Okay, this is the input, this is the output, and the difference between what I had already provided you and the actual output is 4, right? So you can see it is seeing that I know that this equation could be ax plus b, but I don't know what is a and b. I have to figure out what is a and b also, right, to predict the output of 5. Is this part clear? I think this is a little difficult to understand, but I want to take a pause over here and see if this is clear or not.
Yeah, I'm clear.
Hey, hey, Anjali. Any questions, Anjali, from your end? I don't know if you're speaking something, we can't hear you. Is it a problem just with me, or you guys also cannot hear her?
No, I can't hear Anjali.
Okay, sure. Okay. But yeah, Swati, is it clear for you? Anjali, maybe you need to check your earphone settings or your laptop setting once. We can't hear you. Yeah. Swati, is it clear over here? What are we trying to do in this?
Yes, yes. So once it forms the equation, it is again going to verify whether it's correct or not, and then only it will give a final
Yeah.
output, right?
Yeah.
Mm.
I have just right now the model just has a basic understanding that it could be a pattern like this, right? Where I have a variable where I am multiplying the input by something and doing also some addition right over here. But I don't know what is the right value of A or B so that I can predict the value. So what it is trying to do over here is let's predict the right value of A and B, right? So these are also called, you guys might have heard that there are parameters within a model, right? A model is 12 billion parameters or this and that. Machine learning models have parameters. So this A and B are parameters of the model, right? For this simple problem that I'm trying to solve, see how it's coming up with the parameters, right? It's trying to frame an equation that, hey, based on this input and this, first I think that it is something like this, that I need to multiply the input by a variable and then also do some addition over here. Then it's saying, okay, I got this pattern that it could be something like this, but can I prove it based on the data which I have been provided? What is the data that I have been provided? Which is this part, right? So let's use this data to see how correct I am. Because I know for 1, the output is 3. For 2, the output is 5. Let's try to come up with what could be A and B. So let's do a random guessing. I will take A1 and B as 1, and I will see what am I getting the output. So I got this as the output, 2, 3, 4, 5. Then I compared it with the actual output that I was already provided, given this is the training data that I was already given. So I saw that, oh, I have an error in my algorithm. Definitely this is the equation, but A1 and B1 is not the right solution. I have some error. Okay. So what it will do is, now what it will try to do is, it will take some other value. Okay. It will say, let me substitute A3 and B1. So now the equation becomes 3x plus 1, right? So what it will do is, it will predict y dash now. Now I take the value of x is equal to 1, 3 into 1 plus 1. So my output becomes 4. But what was the input data I had already been provided? 3, right? So the error is -1. I see an error. I take it for this data point, 3 into 2 plus 1. My output is 7. But the training data I was provided said that the output for 2 will be 5. So I'm wrong by 2, right? Then it sees that, okay, I have taken the value of A3 and B1 again, 3 into the input data 3 plus 1. So what I'm seeing, my output is 10, but the user provided me, or the training data says that the output will be 7, right? So I see that there's still some mistake that I'm doing. And what is that mistake? I'm calculating it differently by 3 points, right? Similarly for 4 into 3 plus 1, what it sees is my output is 13, but the training data which I had was saying that for 4, the output will be 9. So I'm wrong by 4 points. So what I need to do is definitely A3 and B1 cannot be substituted over here. This will not help me giving the right answer for 5. So it will randomly again take one more value. Similar for A is equal to 2 and B is equal to 1. Again, the equation becomes 2x plus 1. So what I do is 2, for this data point I'm calculating, 2 into 1 plus 1. So I see the output, my output is 3, and the training data which I was given over here, that is also saying 3. Oh, I'm right over here. Now again, let's take for 2, right? 2 into 2 plus 1, right? So it gives you 5. So it will say that, okay, my output is 5 over here, and the training data also said it is 5. So it is right. Then for 3 and 4, again, it will get the right answers, right? 7 and 9. So now it sees that I have no error. I have not made any mistakes based on my past data, right? I could definitely predict that this is the equation. And if I substitute 2 over here and 1 over here, I can predict the value of 5, right? So now it will say, okay, now I'm trained based on the past data. Okay. So now I know that this is the equation ax plus b. And I also know that A has to be taken as 2 and B has to be taken as 1, right? So what it will do is, now for 5, I can substitute 5 into 2 plus 1, which is 11. So it will tell me, okay, 11 is the answer. So did you see how did it come to this conclusion? While Swati, you were able to do it very quickly, but internally how the math is taking care of like making a random guess, then correcting itself, and then see. So what did the algorithm do? Starts knowing nothing, makes random guesses. It made a random guess by A is equal to 1, A is equal to 1, and B is equal to 1. B is equal to 1. It saw that it was wrong based on the training data, right? Or the real answer which was provided. So it thought that, okay, I have to adjust this A and B. So this is what, like how the model adjusts internally. So it said, let me take another value of A. So it took A is equal to 2 and B is equal to 1. Now again, it did the calculation and came up with some prediction. Again, it was wrong. It will keep on repeating this process until it gets it right. Okay. But I still see one problem over here is, here we were making some random guesses, right? Let's say if the problem is very real, right? I cannot go in and do an hit and try and figure out then what is the value of A and B, right? I cannot do a hit and try or use a brute force approach to come up with the exact answer, right? It will imagine it's a very complex problem and there you have to go through thousands of things to figure out, right? It is a tedious process and it does not feels like the system will be intelligent over here, right? So you appreciate the problem that it cannot be like randomly I try the value of A and B and try to come up with the solution. There has to be something better to do this, right? Any questions on this part?
No.
Cool. Sure. Okay, we have to get the system better, right? So this was like how a human could guess it or something, that this is the pattern, this is how I have to substitute, and then you are doing it randomly over here. Okay. But now since in my initial class, in the demo or also in the first class, I said, right, machine learning uses math heavily, right? So now instead of guessing randomly what could be the values of A and B, I will use some mathematics to come up with the right solution, or a structured approach I will take, so that I can come to the convergence fast, that what will be the right value for A and B, instead of randomly guessing the values. Okay. So again, the problem statement is the same. Let's see how it will be done. Again, the problem statement is same. I have some X values. I have this pattern of data where I have X1, and the predict output for it is 3, 2, 5, 3, 7, 4, 9. I know you guys know the pattern by now, that what will be the answer of 5. But how does ML take a structured approach is what we'll be looking at now, right? So we looked at it, that it somehow figures out that this is the equation that is suitable for this kind of data, right? Now it takes a random guess. Let me start by A is equal to 0.5 and B is equal to 0.2, right? So we'll again do the same process of predicting what is my output. So this is my input. I have taken A as 0.5. So the equation Y is equal to AX plus B becomes 0.5, A's value, X, which is the X which I'm getting the input from the input, and then plus B, right? So B I have taken 0.2. So I will not go over the calculation again, because I think it is already clear to you. So what it will say is my predicted Y for the data point 1 is 0.7, right? While the user or the training data told it's 3. So it will figure out the loss or the error which I have is 2.3. Similarly, for data point 2, the predicted Y was 5, but based on these parameters, A and B, my value is 1.2. So I'm still at error of minus 3.8, right? Similarly, for data point 3, I substitute the value and I see 1.7, while while from the input data I already know it's 7. So I'm making a wrong guess. This is the loss I have, right? Similarly for 4, I know that this is, if I substitute by this value, I get this, but the user has provided me that data that for X, when X is equal to 4, the output should be 9. So I'm wrong by this amount of, I'm wrong by this number, right? So I know for each of the data points, I'm getting wrong values. It's A 0.5 and B 0.2 is not the right answer, right? I still know the equation that this could be the pattern, but this is not the right answer. In the previous approach, when I saw that this is wrong, I randomly took another value, right? But now I will not take randomly another value, but I will use a mathematical approach to take the next value, right? So what is the mathematical approach that I will take? I will compute the loss that I have. So what is the loss? I know from this equation, when I computed the last time, that these were my losses. For when the X was 1, when X was 2, when X was 3, or when X was 4, this was my error, right? This we know how we calculated this. Now what I will do is I'll just square the errors, okay? Which is, I just want to keep the values as negative. I mean, everything should be positive. So that's why I'm just squaring the errors now, okay? This was my initial error. I'm just squaring the errors for now, okay? And now I find out what was the average loss that I had, which is just I'm adding these values and then doing a division by 4. So I know that I'm wrong by this amount of value, okay? So the loss should be equal to 0, right? Then only we know that we have come to the right parameter, right values for A and B, right? Here, if you see for A is equal to 2, B is equal to, the error was 0 and the loss was then 0. That is why we could conclude, right? So here what we are doing is we see that the loss is 23.5 and we want to get to a point where the loss is 0, right? So now I have to pick the next value for A and B, right? But how will I do it, right? Okay. So, okay. So this is again the same calculation. I have repeated it over here, that this is what my input was based on these values, right? So we need to figure out how should we change A or B so that I get to the right conclusion. I don't want to randomly pick A and B and do a hit and try. Okay. So here we will use derivatives. Okay. What was derivative from 10th class mathematics? With derivatives, we can measure the rate of change of one thing with respect to other thing, right? So think of it like that, that I have a loss. I know the error, right? But what is, I know that there is an error. Now I want to see what was the impact of A on the error, or what was the impact of B on the error. Okay. So if I calculate that, see, A and B were contributing to the output, right? So what I'm trying to say is, in this particular step, what we will do is we know the loss. Now, how much did A contribute to the error, and how much did B contribute to the error, right? So we are trying to figure that out using derivatives, right? because there is a loss and we want to figure out that how much did A contribute to the overall loss and how much did B contribute to the overall loss. If I have some information around that, I will adjust A and B accordingly. I will take a pause over here and see if there are any questions, because this is one difficult thing to understand. Yeah.
Yeah, so how will it know that it has to use derivative concept? It has to build an equation.
Huh.
How will the system know?
Yeah. So why is it taking derivative? Is like I said, right? It could be integration as well, or or any other mathematical expression, right? So why derivative? Because it measures the rate of change of one thing with respect to other, right? So there is a loss, right? Or there is an error in my predictions, but can the loss, what is the rate of change or what is the value of A I can take, so that how is A impacting the loss, right? If I change, how much do I change A so that the loss reduces, right? So that is why derivatives like measure the rate of change. So that is why like we are using derivatives to come up to the point that how much should I change A or how much should I change B so that the loss is less, right? So that is what it will make sense, Swati. But I mean, are you getting an overall gist? When I talk about the next equations, it will make much more sense.
Okay, okay.
Right? So it figured out that I have to use derivatives because they measure the rate of change of one thing with respect to other. I have loss. I have A and B which are contributing to the loss. How much should I change A and B so that the loss is minimized? Okay. So now what we do is, and I mean, this thing you don't have to memorize or anything, but just to have complete clarity of how this is impacting, I have taken this equation. Ignore it, or if you don't understand it, it's totally fine. Don't get worried that in LLMs or anything, we have to do this kind of mathematics and all. This is just for understanding how derivatives will come to a formula. If I directly tell you, right, that when you have to update A, multiply by this formula, it would have been a black box for you that how did you come up with this formula, right? So what I'm trying to say is my A is 0.5. Now I want to update it with a new value, right? So this is the formula I should use. I could have directly told you this formula, but then it would have not made sense that how did I come up with this formula, right? So that's why I'm explaining everything over here. So how did we come up with this particular formula is we see what is the loss or the error. We know that y dash minus y square minus y. Y dash is what my predicted output and y is my training data, right? Which I told you. Y is like what I was predicting the output and y is my actual thing. And I said that we always we do a square of the error, right? So my error is calculated like this, y dash minus y, and I do a square of it. So now let me tell you, there is one there. I mean, this is also like in 11th and 12th, you might have learned this, that if I have to do a differentiation of x square with respect to y, what is the output for it? 2x into dx by dy, right? Till this point, is it clear? Oh, okay. Let me write it over here. X square, d of x square, I have to do with respect to d of y. So it is 2 into x, okay? And then dx by dy. So this used to be the formula, okay? Again, don't get stressed. It's like I want to give you the formula and I want to give you how it's derived. So that's why I'm taking this into account. So now with this, for y square minus y, I just take 2 and y dash minus y. So which is the error? So I do 2 into error, and then I differentiate this whole thing with respect to a. So I expand y dash, which is ax plus b, and then y is as it is. Now, these two are constants. So for constants, right? So if this is a constant, with respect to dy, if you do, it's 1, right? For constants, it's always 1. So this part goes away automatically because they are constants. 1 minus 1, when you differentiate dv with respect to a, it becomes 1. When you differentiate y with respect to a, it becomes 1. So 1 minus 1 becomes 0. Now let's just focus on this part, which is differentiation of ax with respect to a. So it becomes like x, right? Because d of a and d of a is cancel out. So if I substitute this whole formula like this over here, right, I will get that this is what the value should be. Now, what does this mean? It means that whatever your previous value of a was, right, you need to use this formula to come up with the next value for a, right? So that it's mathematical. And we know that if I change a by this amount, I don't have to do a hit and try and all those things, right? So that is how it is, right? So now I calculate this, like the derivative, okay? Like what is the impact on the loss with respect to a? So I got this formula. Now I will just substitute the values in this formula, which is like x was 1, 2, 3, 4. The error was this. We had calculated this previously. Now I know that to calculate the overall impact, I have to use this formula. I'm just taking this formula. This was my error, and this is my overall. This is my value. This is the overall error. This is how A is contributing to the error. This is how A is contributing to the error, and then I take out an average. Okay. What does it mean is that you can see these are all negative values, right? So what does it mean is like we have to somehow increase the value of A, right? If you see from this equation, every time we were less, right? I was using the value of 0.5, and then I could see is like the actual output was 3, but I was at 0.7. So definitely I have to increase the value of A, right? My given output was 5, but I was like at 1.2. So definitely I have to increase the value of A a little bit, right? Because of this thing. So similarly, we can, when we calculate derivative of loss with respect to B, so we see that what's the impact of B on the loss. So we calculate that. Similarly, like we calculated the impact of loss on variable A, we'll calculate the impact of loss on variable B. We see that the average is 9.1. Okay, this is math. I mean, don't again, just reiterating, don't worry about this math. It is just to have, it is just there so that you have complete clarity. Now to calculate the new value of A, we will use this formula. Old value of A minus learning rate into derivative. Derivative is nothing but this thing which we are calculating over here. Derivative is nothing but the average which we calculated over here, right? See this once again, new value of A is old value of A minus learning rate into derivative. Okay. So what was my old value? 0.5. Learning rate is something which we will look into. I will tell you the definition of what is a learning rate. Learning rate is also a small variable that we use, which controls like by how much you need to change certain parameters, right? So think of it like when you're cooking something, right? You have like low and you have a high, right? But if you want to cook something at a particular temperature, do you directly like turn the knob in such a way that you go to extreme hot or to extreme low, right? You adjust it little by little, right? So that you can hit the right temperature. So learning rate is that variable. Okay. And don't worry about this. This also will take more examples so that we can learn about it. Now, the old A was 0.5, learning rate is 0.3. This is a random value that we have taken. It could be anything. And the derivative, which was the average that we calculated by this thing, is 26.5. So we took 26.5. Now, if we do the calculation, 0.5 minus 0.3 plus this thing, it will come out to 1.3. I'm multiplying over here. Just, yeah, learning rate into derivative, right? So 0.3 into this comes out to be this, and then my new A is this. Similarly, my new B is this, right? So my new values with which I want to try is A is equal to 1.3 and B is equal to 0.47, right? So again, what I will do is, again, I will repeat the same thing with A is equal to 1.3 and B is equal to 0.47, correct? I will substitute the whole thing and figure out the loss, the overall loss that I have. So when I compute the loss overall, I will get 5.81. So you can see over here, my initial loss was I was behind 23 points, approximately wrong. Now I'm wrong by 5.81. It's still not correct, but we are still not, I mean, but very less, right? Now what I will do is, again, I will repeat the same step. I will change the value of A and B so that I can come to the right answer. So this is, I won't repeat everything because it would be too much, but this is how we'll change the values of A and B based on our mathematics, right? I will take the value of A 0.5, 0.3, see the loss, then update it to 1.4, 0.7, see the loss, then again update it based on derivatives that this is the next number that I should go to, and then I see the loss. I'm seeing that the loss is getting close, right? We are getting close to zero. Then I again update. And finally, I'll come to this point wherein I know that if I put the value of A as 2 and B as 1, the loss will be 0. So I know what is the value of A and B in this equation. I know this equation is like this, AX plus B. And I know also that I have to put the value of A is equal to 2 and B is equal to 1 so that I get to the right answer. Now, once I know all this, I will predict the value for 5 easily. This is my equation. This is my A and B. I will substitute it and give you the answer. So what did the machine learning model do? First, it came up with an equation, that what is the equation, rough equation that can help me answer this, right? And then what are the variables, right? It did learn everything by taking a mathematical approach to come up to the right answer, right? So this is what this is what machine learning algorithms do at a very high level. Yeah. So is it clear, Swati? Any questions? I see Anjali has already dropped off.
Oh, okay. No questions from my side.
Sure. So if you relate it to a real life example, right? Let's say if you have to predict the price of a house, right? Now let's map it to a real life example. You have these inputs, right? That the size of the flat is this much. It has these many bedrooms. It has this, I mean, how old is the house? 10 years, right? So the price is 50 lakhs, let's say. Then again, I have this past data that the size of the flat is this, the bedroom size is this, the age is this, the actual price is this lakh, right? So this is my past data, and now what I would do is I will tell it that predict me the price of like 1800 SFT size flat which has 3 bedrooms and is 3 year old. So it will do this whole process that I explained in the past, and it will give you the right answer. So this is how like machine learning algorithms work. Like when you see Swiggy and Zomato predicting the delivery time, this is what is going on behind the scenes. They have a lot of human label data where it tells you that okay, in the past it has taken this time based on these parameters. So it will try to come up with an equation and tell you that okay, now it will take this much time. Similarly for Google Maps, like ETL, same kind of algorithm is used. This was like very math intensive. That's why I gave an heads up that it's today's class is going to be a little maths intensive, but this is the only class which is math heavy. Okay, I had this for this class. Yeah, any questions?